In the quiet highlands of Cameroon, West Africa, lies a lake cradled within a volcanic crater. For centuries, it was a source of life for the surrounding villages, a serene body of water named Lake Nyos. But on the night of August 21, 1986, this seemingly peaceful lake became a silent executioner. In a matter of hours, it released a deadly, invisible cloud that swept through the valleys, extinguishing the lives of over 1,700 people and thousands of livestock. What happened that night was not a supernatural event or a malicious act. It was a rare and terrifying natural phenomenon known as a Limnic Eruption, an underwater explosion of carbon dioxide gas. To understand how a lake can explode, we first need to look at its unique location. Lake Nyos sits in the caldera of a dormant volcano, part of a chain of volcanoes known as the Cameroon volcanic line. Deep beneath the lake bed, magma constantly releases gases, including massive amounts of carbon dioxide. This CO2 seeps upwards through the rock and dissolves into the cold, deep waters at the bottom of the lake. Most lakes, especially in temperate climates, experience a seasonal turnover. The surface water cools in the winter, becomes denser, and sinks, while the warmer, less dense bottom water rises. This circulation mixes the water and allows any dissolved gases to escape safely into the atmosphere. But Lake Nyos is different. It's a tropical, deep lake that is thermally stratified. This means it has distinct layers of water that don't mix. Top layer is warm and less dense, while the bottom layer is cold, dense, and under immense pressure from the water above it. This stratification acts like a cap on a soda bottle. For decades, perhaps even centuries, the carbon dioxide seeping from below was trapped in the cold bottom layers. The immense pressure at that depth, over 200 meters down, allowed the water to hold an astonishing amount of dissolved CO2, far more than it normally could. The lake became a ticking time bomb, supersaturated with a deadly gas just waiting for a trigger. On that fateful August night, something disturbed this fragile equilibrium. Scientists aren't entirely sure what the trigger was. It could have been a landslide on the crater's edge, a small volcanic tremor from below, or even a sudden change in water temperature due to heavy rainfall. Whatever the cause, it was enough to disrupt the stratified layers. As some of the deep, gas-rich water was pushed upwards, the pressure on it decreased. This is exactly like opening a shaken bottle of soda. As the pressure dropped, the dissolved CO2 began to violently erupt out of the water, creating a chain reaction. This sudden release of gas displaced a massive amount of water, triggering a 25-meter-high wave of tsunami that crashed against the shoreline, stripping vegetation. But the wave was only the beginning of the horror. A colossal bubble of carbon dioxide, estimated to be nearly a cubic kilometer in volume, burst from the lake's surface. This massive cloud of gas, being denser than air, did not dissipate into the sky. Instead, it formed a silent, invisible river that flowed down from the crater's rim and into the surrounding valleys, hugging the ground. It moved at a terrifying speed, estimated to be as fast as 50 kilometers per hour, displacing the breathable oxygen as it went. The villages of Nyos, Cha, and Saboom lay directly in its path. People in these villages were asleep, completely unaware of the deadly cloud descending upon them. The CO2 is odorless and colorless. There was no warning. As the cloud enveloped the area, it silently suffocated anyone in its path. People and animals simply stopped breathing, dying in their sleep or collapsing where they stood. The few survivors who were on higher ground or at the edge of the cloud's reach woke up to an eerie and devastating silence. They found their family members, neighbors, and livestock lying dead, with no signs of struggle or injury. The initial reports were confusing. Survivors spoke of a rotten egg smell, which led to initial theories of a hydrogen sulfide release. However, the sheer scale of the tragedy pointed to something else. When rescue teams and scientists finally arrived, the scene was apocalyptic. The once vibrant communities were now graveyards. The only signs of life were the buzzing of flies. Dr. Michel Halboix, a French volcanologist, and his team were among the first to piece together the puzzle. They analyzed water samples from the lake and found them still fizzing with CO2, confirming the theory of a limnic eruption. The world had seen this before, but on a smaller scale. It's just 2 years earlier, in 1984, Lake Monoun, another crater lake in Cameroon, had released a CO2 cloud that killed 37 people.
The warning signs were there,
but the potential for a catastrophe on the scale of Nyos was not fully understood. Once the cause was identified, the next critical question was, could it happen again? The answer was a terrifying yes. Scientists discovered that CO2 levels in the lake were already rebuilding, seeping back into the deep water from the magma below. Without intervention, Lake Nyos was on track to erupt again within decades, potentially with even greater force. The surrounding communities, though traumatized, had begun to return to their homes. Living under the constant threat of another silent disaster, a global effort was launched to make the lake safe. The solution proposed was simple in concept but challenging in execution: to create an artificial way for the trapped gas to escape safely and continuously. In 2001, scientists led by Dr. Hal Brox installed the first degassing pipe. This pipe was lowered to the bottom of the lake, and a pump was used to draw the deep code torch water up to the surface. Once the flow started, the process became self-sustaining. As the water rose in the pipe, the decreasing pressure caused the CO2 to come out of solution, forming bubbles. This bubbly mixture was less dense than the water around it, creating a powerful fountain effect that shot water and gas high into the air, much like a geyser. This pseudo straw method allowed the gas to be released in a controlled, continuous manner, preventing a dangerous buildup. The first pipe was a success, but it wasn't enough to remove the gas faster than it was accumulating. Over the next decade, 2 more pipes were installed, significantly increasing the rate of degassing. Today, these pipes stand as permanent fixtures on the lake, constantly releasing plumes of water and gas, a visible reminder of the invisible danger that lurks below. Thanks to this remarkable feat of science and engineering, the concentration of CO2 in Lake Nyos has been reduced by over 90%. The lake is now considered safe, and the threat of another catastrophic eruption has been neutralized. The story of Lake Nyos is a powerful lesson about the hidden forces of our planet and the incredible ability of science to understand and mitigate them. It's a tragedy that led to a triumph of human ingenuity, turning a killer lake back into a life-giving source of water. This incredible work has saved thousands of lives and ensured that the silent killer of 1986 will not claim any more victims. If you found this story fascinating and want to learn more about the incredible and sometimes dangerous world we live in, make sure to subscribe to Curiosity Repo.